purpose of this video is to talk about density and heat movement. First, density means the amount of matter in an object. Another way that you could say it is how tightly the amount of matter is packed together. If we look at the picture on the bottom left, all of the spheres, the yellow spheres, are tightly packed and they're very close together. That's an example of high density. It doesn't matter what the yellow spheres are. They could be hydrogen atoms, they could be sodium atoms, they could be water molecules. It doesn't matter. We'll just call them particles. And they're high density because they are packed together tightly and there's not a lot of space in them. If something has a high density, you would say that it would sink in something else. So you would say an iron nail has a higher density than 100 milliliters of water. It would sink because of that. In the picture to the right, the orange spheres have a low density. Those particles are loosely packed together and there's way more space between them. So because they're loosely packed together, there's more space, those particles would float. So a wood block would float in a glass of water. If we look at the graduated cylinder to the right, there's a couple different colored liquids. When we're talking about density, and we're talking about a high density, we would say that the green liquid has a high density compared to the other liquids because we find it at the bottom of the graduated cylinder. Whereas if you're looking at the blue liquid, you would say that that has a low density because we find it at the top. So the blue is less dense than the green because it floats on top of it. Temperature also affects the density of the particles. And if we look at the examples of the three particles, red, orange, and blue, the red particles have the highest density because they're the most tightly packed together. The blue particles have the lowest density because they're the most loosely packed together. So let's go ahead and fill in our density. The density increases as you go from right to left. Okay, so the particles on the right in blue are the least dense, and the particles in red are the most dense because they are most tightly packed. What happens when you increase the temperature, though, is that the particles will get excited. They'll get energized because you're adding heat energy to them. So they'll do a couple things. One, they're going to get excited. They're going to move faster, and they're going to move further apart. So in the example on the left, the red particles, the highest density, that would also be the lowest temperature. The orange particles in the middle would be, medium temperature, and the particles on the right-hand side would be the highest temperature. So when the temperature increases, you're adding energy, but the particles move faster and they spread further apart. So as the temperature increases or goes up, the density goes down. The particles will become less dense. Okay, there's three types of heat energy transfer. The first one is called conduction, and conduction is a direct transfer of heat energy through touch. So an example of conduction would be a pot of boiling water or heated water on the stove, and you pick it up and touch the handle that is hot. That would be heat energy transferred through conduction. The next type is something called convection, and that is heat transferred through the air or a liquid. And you can see that the water is being heated. The heat is moving through the water, through the liquid. And then the last type is radiation, and that is heat energy transferred through wave motion. Okay, so not direct contact, not through the material itself, the liquid or the air, but through the form of waves. Now, in the mantle of the Earth, we have these things called convection currents. And in the mantle, that plastic material gets heated up. And because it's heated, it becomes less dense and it rises. Okay, once it rises, it becomes cool as it moves away from the heat source, and then it sinks back down, only to be heated and rise up again. And that's the process that's taking place in Earth's mantle. And of course, the heat comes from the core.